My name is Michael Retchen. I am a sophomore at Columbia College. I'm majoring in computer science and interested in genomics, and I'm representing Columbia Organization of Rising Entrepreneurs, which is the largest student undergraduate entrepreneur society at Columbia. And I'm so delighted to introduce Jeannette Wing today. Jeannette comes to Columbia from Microsoft, where for the past 4 years, she has been corporate vice president of Microsoft Research, overseeing a global network of research labs. She is widely recognized for her intellectual leadership in computer science and is now helping to define the new emerging field of data science. Jeannette's seminal essay titled Computational Thinking was published more than a decade ago and is credited with helping to establish the centrality of computer science for problem solving in fields where it previously had not been embraced. Before joining Microsoft in 2013, Jeannette held positions at Carnegie Mellon University and the National Science Foundation. She served Carnegie Mellon as head of the computer science department twice and associate dean for academic affairs. At the National Science Foundation, she was assistant director of the Computer and Information Science and Engineering Directorate, where she oversaw the federal government's funding of academic computer science research. Her areas of research expertise include security and privacy, formal methods, programming languages, and distributed and concurrent systems. Jeannette has been recognized with Distinguished Service Awards from the Computing Research Association and the Association of Computing Machinery. She holds bachelor's, master's, and doctoral degrees from MIT. Thank you so much.
Thank you very much. I am delighted to be here to speak to this audience, very entrepreneurial spirited audience, I understand. I am new to Columbia. I joined last July, and I want to really thank the Columbia community for being so welcoming and warm and gracious. It's just been a thrill for me to be here. I am running the Data Science Institute at Columbia University, and before I talk about the main topic of my talk, which is data for good, I wanted to share with you my mission statement for the Data Science Institute. I should be very honest with you. A lot of my talk, Data for Good, will actually be more about why we should be a little scared of AI. In other words, scary AI and the dangers of big data. So let's get on with my mission statement. I have a three-part mission statement for the Data Science Institute at Columbia University. The first is advance the state of the art in data science. This really means pushing the frontiers of the research of the field. And what's interesting about this part of the mission statement is, of course, data science is a new emerging field. So we get to define what data science is. And I'd love to be able to say 10 years from now, looking back, that Columbia University helped define the field of data science. We are ahead, and I love being in a leadership position, and I want to maintain Columbia's leadership in data science. The second part of my mission statement is to transform all fields, professions, and sectors through the application of data science. And what has been so gratifying to me in coming to a full-fledged university like Columbia is that data science already touches every corner of the university. I have engaged with faculty, administrators, deans, chairs, and so on throughout the entire university, all the schools, and there's data science happening everywhere. The students are engaged, the new faculty recruits are all trained in machine learning and data science. It's really quite remarkable. And it goes to show that Columbia is really quite with it. The last part of my mission statement is germane to the topic of my talk, and that is ensure the responsible use of data to benefit society. And of course, there are actually two parts to this. Of course, we want to use data science and any technology that we invent for the good of society, to make sure that we're addressing societal grand challenges like healthcare, energy, climate change, and even education. But the part of the mission statement that's truly unique to, I think, data science at Columbia University is responsible use. And this I almost don't even need to argue why we should be looking at the fair and ethical use of data, because the headlines write this for us every day. Now, I came in July, and I stuck my neck out and wanted this to be a core part of the Data Science Institute's mission, and I feel like I've hit a nerve. So I'd like to summarize my mission statement for the Data Science Institute at Columbia with this 3-word tagline, data for good. Data for good, of course, means using data to benefit society, for the good of society, but it also means using data in a good manner, and that's the responsible use part. So I'm only going to focus on the responsible use because I think that's such a timely topic, and of course, it's something that I really want to emphasize to the entrepreneurs in the audience, that you need to be paying attention to this now when you start your company, and the designers and the engineers should be paying to these issues now, not after the fact. To be honest, you do not want to be in the hot seat that Mark Zuckerberg is going to find himself in on April 11th in front of Congress. So that, you get it? All right. So what do I mean by responsible use? I use this 5-letter acronym, FATES, Fairness, Accountability, Transparency, Ethics, Safety, and Security, to summarize, just as a checklist reminder of the kinds of properties that we would want of the systems that we build and design to have. To you and me, some of these properties look a little squishy, and that's the nature of the beast, but it also is a challenge to the technical community, and by that I mean the scientists, engineers, mathematicians, and so on, to formalize some of these definitions, to build tools, automated tools that can help check our models, our algorithms, our data sets against some of these properties. What I want to do in my time with you is just to run through very, very quickly what I mean by some of these properties through examples, what progress has been made in terms of the technology for checking some of these properties. And believe me, this is all very new. It's not like there's a book written on any of this. And some of the articles that I cite are 2017 publications. This is all really, really new. We're still trying to figure this out. But as you can tell from the headlines, it's an important topic for us to figure out. So let me start with fairness. And before I can tell you some stories that can motivate why understanding and checking for fairness is so important, let me start with a little primer on setting the context in terms of machine learning, AI, and so on. So first of all, we start with an algorithm. So this is a bread and butter artifact that we invent. In computer science, we invent algorithms all the time. Algorithms are used everywhere. They basically take a set of inputs and produce an output. In this particular case, think of the inputs as being data. It could be big data. It usually is big data these days. And I'm not distinguishing between training sets and test sets, just data, lots of data. We start with the data, we feed it into the algorithm, and what's the output? A model. And this is what I mean by a machine learned model, because the algorithms I'm thinking about are machine learning algorithms. With this model, this is what people are really interested in producing with these algorithms. When I give you new data, brand new data you've never seen before, the model is able to do a classification or do a prediction. In the context of this talk, I'm just going to simplify matters. So a classification output might be, if I give you an image, you say there's a cat in the image. It's as simple as that. So it's a cat classifier for images. You know, I might have a different classifier that says there's a dog there, or there's a person there. I'll say, so the model is going to produce a classification. It's a cat, the image is an image of a cat, or it's not. Binary. Or the model might predict something. So it might predict where you're going to click next. It might predict how long you're going to spend looking at this item on Amazon. It might predict what movie you're going to watch on Netflix next. Everything we do on a daily basis with the web, with the digital world, there's some prediction going on based on all of our behavior in the past, and I don't even have to spell this out for you because you're reading the news as I am. So in any case, what can go wrong? What can go wrong? Well, there might be, what people have been criticizing that algorithms might be biased. I'd rather turn your attention to something more fundamental that might be biased. And that is the data you feed into the algorithm might be biased. In fact, the data that you feed into the algorithm very likely will be biased because all that data is reflecting real-world data, and real-world data likely inherently is biased. So you start with biased input, and you basically taint the entire pipeline, potentially. And anything, the model might be biased, and the classification might be biased, the prediction might be biased. You kind of hose from the beginning. So that's the situation we're in. And now let me explain some examples of where this bias has shown up, which is alarming to us as citizens in society. So the first example is this very well-known example that came out of an article by ProPublica. How many just have heard about this story? Okay, so that's not enough of you. This ProPublica article raised the awareness of the public to the potential that there's bias in data and thus bias in the model. What this article said is that there are these proprietary algorithms that are used by judges in the United States to determine whether the risk of reoffense, recidivism, they use this black box to give a risk score to a defendant. And the ProPublica article said that this risk score, this black box, was almost twice as likely to mistakenly flag black defendants than white defendants. So this clearly doesn't seem fair, especially in the laws of the United States, and there was an uproar. You should realize that this risk score can go wrong in both directions, if you will. It can give a low risk score to someone who will reoffend, and it could give a high risk score to someone who will not reoffend. So it can go wrong in both ways, and sure enough, this ProPublica analysis showed that this black box algorithm went wrong in both directions. And that caused a lot of excitement and brouhaha, and lots of people then subsequently looked at the data that ProPublica was able to get from this company, and there were white papers done by various communities, but it all settled down eventually with some technical people, some colleagues of mine in computer science that basically said, you know what? It's actually impossible to satisfy two different reasonable notions of fairness at the same time. What the black box was doing was trying to satisfy one particular notion of fairness, and what ProPublica was arguing for was a different notion of fairness, and these two notions of fairness are incompatible. And there's basically a paper that spells this out mathematically, and on the one hand, this kind of settled the argument, settled the debate in the community, but the most important thing from my point of view is it raised the awareness that there's not necessarily one notion of fairness that makes sense for all cases, all contexts, all situations. here's another example of, or in fact, another notion of fairness that actually had been defined even earlier in 2012 by a former colleague of mine at Microsoft Research, Cynthia Dwork, and her colleagues. In this notion of fairness, the idea was treat similar individuals similarly. So, for instance, if you have two individuals and you look at their features and you can sort of say they're kind of similar, then any action you do on either of those individuals should be the same. So for instance, if I have a man and a woman, then they look pretty similar in terms of their qualifications, then I should offer each of them a job because they are similar. That would be the similar treatment. Well, it turns out that, so this has been also studied as a formal definition of fairness, and it has its other strong ramifications as well. I won't go into that. As another example of fairness or unfairness, some colleagues of mine at Carnegie Mellon had done a study on Google, using Google, I should say, not on Google, using Google, which resulted in a New York Times headline that basically said, higher paying jobs were shown more to men than to women. This also caused a lot of excitement in the community because in this particular case, it was not actually clear who to blame. And that leads me to my the next letter in the acronym, accountability. So, okay, so now we see that maybe some discriminatory behavior has been exhibited, or there's some unfairness in some way. What should we do about it? First, let's figure out, well, who or what is to blame? Well, even in this example of higher paying jobs shown more to men than to women, it's not clear. Like, do you blame the advertiser who was targeting the ad? Do you blame Google that actually explicitly programmed the system to show the ad less often to females? Do you, I mean, is it the community? Males and females actually respond differently to ads. Maybe there's competition for advertisers to females that suggested that that a certain ad would be much more interesting to females than to men. Some third party. Maybe there was a hacker. I mean, who knows who's to blame? Because Google, in some sense, is a very big black box. So that's the question of accountability. Who's to blame? Or what's to blame? Because it might be a bot. It might be a program. I wanted to say that it's not like this is a hopeless cause. Some colleagues of mine, again at Carnegie Mellon and Microsoft Research, and I had been working on a different problem that gave us some hope that there was some if not automatic way to determine accountability in a narrow context. And the question is, if you are responsible, so for instance, you are the company and you publish a privacy policy and you realize that there's a violation to the privacy policy you've published, well then you are clearly responsible for fixing that violation. And this was something that I'm speaking now specifically about some work that we did at Microsoft, and that is we showed that you can actually automatically do a check of the officially published privacy policy of a large corporation to detect violations. So typical privacy policies, and now I think many more of you are reading these as opposed to clicking through them, but typical ones are, screens full of English language text that says we'll store some data separate from other data, we'll delete some other data after a certain number of days. All these privacy policy statements that many of us probably never read. Well, they're in the terms of agreement in any service or product we buy. So we built a tool that uses pretty off-the-shelf programming language techniques, static analysis techniques, to basically run through an entire code base to find violations of such privacy policy. We had to invent a formal language so that we can codify the policy. This tool is run, and these are 2014 numbers, these are Microsoft numbers, it's run every night. And this is the kind of tool, you can see the millions of lines of code, the number of changes that happen every day. It's one of the things, these sorts of things you cannot do manually. But thanks to computer science techniques and a lot of engineering, good engineering, it is a kind of tool that scales and can be run fairly quickly. So this only takes about 30 minutes every day to run over the entire, in this case, it was the Bing code base. And you can now imagine, for those of you who are familiar with EU GDPR, that this is the kind of tool that is it would be very useful to have for running internally for any company to ensure that the EU GDPR privacy policies are going to be complied with. Okay, so that's fairness, accountability. What about transparency? And for transparency, that really means, is there a way that I can understand the output that, the classification or the prediction, the output of the model? Because right now these models are black boxes. And in the end, it's going to be some doctor that has to make a decision based on that prediction that, oh yes, well that looks like a tumor cell, because some black box model is looking at the image and saying, yeah, I think there's a tumor cell there. So why should the doctor trust this decision, this output? Transparency will help. And the reason I want to just focus on deep neural networks, so how many of you heard of deep neural networks? Everyone's hand should be raised. Okay, this is the hottest topic in AI. This is what's driving this AI revolution, sweeping all corporations around the world. It's DNNs, so if you don't know about deep neural networks, you probably should learn about them. And it's astounding to me as a computer scientist, the number of successful applications DNNs has had. However, that's great as a practitioner. However, as a scientist, we are clueless as to why they work. In other words, they're not very transparent. And so here we have this great technology that is beating the world's records in image recognition, speech recognition, machine translation, you name it. All these things that we thought were going to be difficult AI tasks. It was part of the system that beat Go, the Go human Go player. So this astounding technology, we don't understand why it works from a scientific point of view. So this is now the challenge to the science community. Let me just show you how easy it is to manipulate these DNNs, or not so much manipulate the DNNs, but the output of the DNNs. So here's a great example of image recognizer. On the left, you see a panda bear, a picture of a panda bear, and the DNN classifies this panda with 57% confidence that it's a panda. All I do is add a little noise, that's the middle picture, do some multiplication of the pixels, and I produce an output picture that to you and me, looks like a panda, but this DNN classifier now thinks it's a gibbon with even higher confidence. It's not a gibbon. I mean, it doesn't look like a gibbon to me. A gibbon is a monkey, and pandas are bears. It's not even getting that type right. Of course, if you look closely, you can see why it might think it's a gibbon, because if you look at the eyes and so on, you can always imagine answers to that. But this goes to show how easy it is to basically produce the wrong answer from this black box. Here's another example, and this is now getting closer to home in terms of self-driving cars. So we can manipulate images, and in this particular example, I won't walk through the details, but we can manipulate a stop sign by just adding a little graffiti on that stop sign and fool a self-driving car into thinking it's not a stop sign. And if we can do that by just putting a little black patch on the stop sign and fool the self-driving car into thinking it's not a stop sign, what does that mean? It means when we're driving through that intersection, we could crash. Not good. Here's something more alarming. It turns out that what I showed was a manipulation of images. We can also manipulate audio. And this is an example of where the researchers basically took videos of Barack Obama speaking, and through manipulation was able to make Barack Obama say anything. So here we are all worried about fake news and everything. Well, this is the ultimate. Okay, now I'm scaring you enough? Okay. So I already mentioned EU GDPR. I think they have 4 pillars of the Privacy Act: right to access, right to be forgotten, and data portability. But the one that really is quite a challenge to the science community is what's called right to explanation. And the reason I say it's a challenge to the science community is, as I mentioned already, these DNNs are quite powerful, but we don't know how they work from a scientific point of view. So how can we give an explanation? This is an area of active research. It's so active that DARPA actually put a program together called Explainable AI to promote, to push the scientific community to start addressing this very, very important, hard challenge. So now let me get to ethics. How many people here have heard of the trolley car problem? Well, this trolley car problem is a canonical ethical question. Basically, it says, which is better, kill 1 person or kill 4 people? There's no right answer to that. But our self-driving cars are going to have to start making those kinds of decisions. And now, all of a sudden, we have to face, as technologists, these kinds of ethical questions, and we can't run away from them. And this is again, I hate to bring up recent events, but these are, the Uber self-driving car. We don't know why the problem is, but we are already seeing self-driving cars killing people, or cars in self-driving mode killing people. And so we do know that the first incident of the Tesla crash back in Florida in 2016 was due to very likely the image system getting confused, not expecting a bright white van against a bright blue sky. Also, of course, I don't have to argue the importance of all of this in terms of the implications on the political system, and most recently, the Cambridge Analytica harvesting Facebook data that was affecting now 87 million Americans. So there are ethical questions in terms of the data we collect, especially about individuals, and about what we do with that data. That's basically the bottom line. And it really hit me home when I was at Microsoft and we produced a chatbot, a 17-year-old, edgy, young female, very engaging, hip chatbot. Her name was Tay. We released her March 23rd, 2016, and within 24 hours we had to take her down. And this is because she started repeating the most inappropriate, offensive, ugly language you can imagine. It was horrible. It was absolutely horrible. And she got all that by repeating what was basically being tweeted in Twitter feeds. It was the underground of the internet trolls discovered her and made her repeat all these bad things. This was a lesson for us at Microsoft. It's not that we didn't think about it, but we had to think much harder about the ethical implications of what seemed to be, an innocuous, cool, chatty, hip teenager. Not real, of course. So that was quite a lesson, and I think companies like Microsoft, Google, Facebook, and so on, all learned from that. Let me turn to the last letter in the acronym, which is S. Michael is signaling me I have 2 minutes left. S stands for safety and security, and I'm just going to talk about a very small example to say that we are making progress. And I'm going to talk about this again in the context of self-driving cars. And I'm very proud to talk about this example because it's work done here at Columbia University in our computer science department. And it is very recent work, 2017, and it got the Best Paper Award. So, yay! It's not my work, it's my colleagues' works, but I love bragging about my colleagues. So what they were able to do was basically systematically look at deep neural networks and generate images that would cause the DNNs to classify the image incorrectly. So for instance, they took an image on the left you see, which rightly tells, the classifier rightly says veer to the left, and they modified the image just slightly by darkening it, which would be a natural thing. You know, we don't always drive in bright sunlight. And then the classifier does the wrong thing and says veer to the right. This can obviously cause a fatal error. And they found thousands of fatal errors in 15 state-of-the-art DNNs for the most used image data set called ImageNet for self-driving cars, and for actually also for finding this in malware. So this is really great work. It's the tip of the iceberg of what we could be doing. So let me remind you of my acronym: Fairness, Accountability, Transparency, Ethics, Safety, and Security. I have a lot more story to go with each of those letters. One question you might ask me as a technologist is, what can we actually do? Let's be constructive. And starting from the output, working backwards, we can actually output probabilities and distributions, not just it's a cat, you will click here, not just these binary decisions. We can publish our algorithms and our models and our parameters, and we can also provide individuals data collected about them. This seems obvious to me, to all of us today. It must have been a really novel idea a few months ago. Okay, there is a lot of interest now in the community about regulation. Should we regulate AI? What should it look like? Should we regulate Facebook? What should that look like? And I'm not going to go into that. I just want to say that companies do care. It is their bottom line. After all, customers, we are their customers. And there are new questions for the society in general, but certainly for the science and engineering community more specifically, to address in terms of data science, machine learning, and AI. So thank you very much. Remember my tagline.